Power and energy are possibly the most confused terms in electrical applications. This video will aim to grow your understanding of power and energy. Let's think about energy. The basic definition of energy is the potential to cause a change. In an electrical sense, this would be the energy required to cause an electron to move. Think of it like a bucket of water. A full bucket of water is a full bucket of energy, and an empty bucket is an empty bucket of energy. Let's think about power now. Power is defined as the rate at which energy is produced or consumed. In other words, how fast you can fill that bucket with water. Think of a small garden hose as opposed to a fire hose. The fire hose will fill that bucket up much faster as the rate of water or energy it produces is much higher. Let's bring this into the theory of power and energy. If power is the rate at which energy is produced or consumed, then power can be represented as energy over time, or voltage times current. Using Ohm's law, you can then derive that power also equals voltage squared on resistance, or current squared times resistance. And because power is the rate of energy production or usage, energy is power times time. This is usually measured in watt-hours for electrical applications, as in joules the numbers would be far too great, as 1 joule is only 1 watt-second, and most applications of energy and power are in hours. Let's do an example now. A light bulb requires 2 volts and 5 amps to operate effectively. How much energy in kilowatt hours will this light bulb use in 1 year if it is powered 24/7? If electricity costs 25 cents per kilowatt hour, how much does this light bulb cost to run constantly for the year? So as power equals voltage times current, you get 2 volts times 5 amps, which means that this light bulb is drawing 10 watts of power. 1 year is 365 days times 24 hours, which is 8,760 hours in a year. And as we defined earlier, energy is power times time. So we have 10 watts times 8,760 hours, which gives us 87,600 watt hours of energy used in the year. And as 1 kilowatt hour is 1,000 watt hours, this means that the light bulb used 87.6 kilowatt hours of energy in the year that it was on. So as the cost is 25 cents or $0.25 per kilowatt hour, we have $0.25 times 87.6 kilowatt hours, which gives us $21.90. So this means that the light bulb costs $21.90 to run for the whole year. Thank you for watching. I hope you have gained a greater understanding of power and energy.